tell us that there's a 50% chance that an agreement would be reached on salaries. So this full circle needs to add up to 50. Now, there were people, like I know, it happens every year, that just plug 50 right here. No, these two sections need to add up to 50. So if I do an X and a Y, X plus Y has to total 50. The chance of making an agreement on insurance was 70. 70 is not going to show up at all. Y plus Z is going to have to equal 70. There's a 20% chance that there's no agreement. So what that tells us is that these three need to add up to what? 80. Okay? Well, if X plus Y is 50, so if that's 50, 50 plus what gives you 80? 30. So this is 30. Then you can go backwards because insurance is supposed to add up to 70, so this is 40. And salaries is supposed to add up to 50, so that this is 10. So there are what your percentages should have been. And then we can actually answer the question. The probability that an agreement will be reached on both issues, 40%. Now, the follow-up is really my big concern here. So, number one, you're being asked to determine independence or not. So, anytime you're asked to determine independence, this is a huge takeaway. There are only two probabilities that you should have to check. You shouldn't have to compute any more than the two different probabilities. So on the flashcards that we did yesterday, and this came up, it's the probability of one thing by itself. So let's do the probability of salaries. And you compare that to the probability of salaries again, given insurance. So that's issue number one, is only calculate two probabilities. Okay? And it's the probability of the same thing, salaries in both cases, but one of them is under another conditional. So the probability of salaries, if you're calculating that, we don't have much of a problem with that. That's 50%, so 0.50. The given probability needs some work. So let me explain this. Given insurance means you have to be in the insurance circle. So this should be your denominator. Whatever comes second is your denominator. So, and it's not only insurance, so not the 30 number, but anybody that's in that insurance circle at all, so out of 70. And then people were doing the probability of salaries, and they were just grabbing this 10 number. No. You're only looking at the insurance circle. Out of that insurance circle of 70, that's your given, how many of those 70 were also agreeing on salaries, and that's your 40. So loosely speaking, this is the probability of both, right? Okay, so I would put 40. Now let me do something for you that I want you to write on your note sheet. At the top, if I do the probability of A given B, that essentially means probability of B, not only B, probability of being in B at all. And on the numerator, it's the probability of both. I've never presented it that way before, but I'm hoping that that's helpful for some of you. A given B, so B is your denominator, and then the numerator is the probability of both. A lot of people are doing the probability of just A. Does that make sense? So if I look at this again, insurance, that's your denominator, 70, and then both is your 40. Okay? Now, 4/7 is 0.57. So your probability of reaching agreement on salaries, did it change? Yes, it increased. Meaning, if you made an agreement on insurance benefits, there was a 7% higher chance that you would make an agreement on salaries. It should make sense that there's some sort of correlation there, because if you made an agreement on insurance benefits, then maybe you're just more agreeable people. So So you're slightly more likely to make an agreement on salaries as well. So because being an insurance agreeing person, you had more of a chance of agreeing on salaries, these are not independent. Something about making an agreement on insurance made us a little bit more likely to make. So it seems like sort of a cause and effect relationship. So we would say not independent. Okay? And then we had a similar issue with 6, presented differently, but still there should have been a Venn diagram. And most of you did a Venn diagram, and most of you actually did it correctly. So I gave points for that. But you can't do P given K without first knowing the probability of K, because that's your denominator, right? Probability of P given K. So your denominator is just K. What's your percentage chance of Key Club? 2.3%. 2.3% is a member of Key Club, so that would be on your denominator. And then the numerator is the probability of both. Actually, they did show you that, right? 1.9. So, and there were people that got this right without the Venn diagram. So that ended up being 0.826, which is an 82.6% chance. But if you did a Venn diagram, it wasn't terrible because they told you both. I'm going to call this physics, and I'm going to call this Key Club. They told you both, so this was 1.9. And then your Key Club total was supposed to be 2.3. So you're only missing 0.4 to make that 2.3 total. And then physics 8.6, we already have accounted for 1.9, so that's 6.7. Okay, so if you're not doing, if you're kind of using your diagram, given that you're in the Key Club, so out of these 2.3%, there's our denominator, how many of them are also in physics? 1.9, aka how many are in both? 1.9. Okay, so what does this mean? Okay, it means that if we know someone's in the Key Club, given Key Club, if we know someone is in the Key Club, there's an 83-ish% chance that they're in physics. That's ridiculously high, right? Okay, so if you're in the Key Club, chances are you're also in AP Physics. Vice versa might not be true. I don't know. If you're in AP Physics, that's like, what, 8.6%? Of those 8.6, only 1.9 are also in Key Club. So that's not as high. But if you are in the Key Club, there's an 83% chance that you're looking at someone. If you go to that Key Club meeting, 83% of those kids are also in physics, is the idea there. And that's kind of not what the basic interpretation was. This one. Okay. Again, there's no stepping you up to the final question. They just hit you with it. Is your preference for music independent of your gender? Now, this one was tricky, I think, because they weren't specific about which gender and which style of music. I think we would have done better on this if it said, do the data suggest that males being a male and liking rap are independent of each other? And because they didn't give you direction in that way, my oh my, some people calculated literally everything under the sun, right? That was not necessary. Independence only requires 2 probability calculations, and that's it, okay? So, Lydia, we'll just use you and go around the room. If Lydia chose the gender male and chose techno, okay, she would have to calculate the probability of male, and she would compare it with the probability of male given techno. Then she's done. She's done. That's all she has to calculate. Now, Andy might also do the male and techno, but Andy could do this. Probability of techno versus the probability of techno given male. And she would be done. Okay? Connor might decide to do male and rap. So he might do the probability of male, and he might then compare it to the probability of male given rap. That would work. But no person should be doing all of these. Okay? Bo might do the probability of rap versus the probability of rap given male. So he's kind of doing the same thing as Connor, but not really. He will get different answers, different numbers. The fact of the matter is it's the comparison, and nobody would get those two to be equal. They all change, which means they're all independent of each other. Or, I'm sorry, they're all not independent, because there's a seemingly cause and effect. Yep, you may go. Obviously, people could pick female in techno, female in rap, female in country, but nobody should be doing more than 2 calculations. So let's just do this first one, pretending we're Lydia. The probability of male. Okay, so we are better with given probability for some reason from a chart than we are a Venn diagram. But our totals were 94, 106, 45, 65, 90, and 200. Okay, so our probability of being a male was 94 out of 200 people. And we're comparing that to the probability of male given techno. So given that we're dealing with techno, techno is our denominator, 90. So out of those 90, who's also a male, 36. Or you could say, kind of our new presentation is, how many are in both male and techno? 36. Either way, it's 36 out of 90. Either way you perceive that. So 94 out of 200. Okay, there's a 47% chance that anybody we surveyed is male. Well, if we limit it just to the people, if I take the group of people that loved techno the most, and then I look at those people and decide how many of them are male, 36 out of 90, that would be 40%. So our chances of being a male dropped when we were limited only to techno people, which means our guess is that techno's more of a girl thing, is what that would tell us. Okay? Could be coincidental based on who we sample, but that's what this data is showing us. The fact of the matter is they are not equal, so they are not independent. And that, we would never write this, but that means that there's probably, something to the connection between gender and the style of music that you like. Okay? That's it for probability. I'm just going to go over this one really quickly because it didn't go well. It went well for some people, but this was a kind of a spiral type question. Why is the cosecant equal to 1 over y? Well, the first thing you'd have to say was, well, cosecant is the reciprocal of what? Sine. So the first thing you would want to say is the sine of theta, and based on SOHCAHTOA, sine is opposite over hypotenuse. Yes? This xy coordinate means that this is x, this leg of our right triangle is y, and we're in the unit circle, so your hypotenuse is 1. So the sine of your angle is opposite over hypotenuse. And since cosecant is the reciprocal of sine, the cosecant is just going to be 1 over y. That's all. Okay? It wasn't difficult once you see it, but, people struggled with that one. Okay. So on the sheet that you picked up on the way in, I asked a boatload of probabilities with a Venn diagram and probabilities with a chart. So, first of all, we'll just go around the room. Aiden, what do you think the fraction is that's going to give us the probability of of owning a cat?